Hello, we're back from break and we're going to start working on our Chapter 8 exercises. Here's a listing of the exercises we hope to complete. The one thing that I do want to point out is the first exercise that we're going to tackle is based upon an exercise, an in-chapter exercise from Chapter 5. And when you read the description for that exercise, you'll see that it refers to a particular file. And so what I've done for you as a courtesy is I've attached the file to the exercise so you can just download it here and pull it in. Those that are here in the classroom, we use a different mechanism called code share to get uh, the code to everybody. But either way, as long as you have that file. So basically what we're going to do is we're going to open up that file and we're going to alter it to switch from whatever approach was used in Chapter 5 to a more modern approach that we're going to use from Chapter 8. So let's jump over to the book and read the first exercise description. It says, write a new version of the program intName.py from Chapter 5 that uses a dictionary instead of if statements. Right? And we also learned from the lecture just now that when you start running a bunch of if statements, there's kind of an extra step of processing that happens, and that's kind of one of our goals here too, is to make the program more efficient. So in my side window here, my screen number 2, I have my Notepad++ running where I've already got that mentioned program intName.py opened up, and I did a Control A and then a Control C to copy. The Control A, of course, selects all, and then Control C is the copy. Now I switched back over to Spider, and I have a new file already waiting to be named. So I'm going to start by doing the naming. And I'm going to go ahead and, of course, store this in the same location that I've been working in. So I have a subfolder here for Python, and we're going to make a new folder for Chapter 8. All right, and that's where our work is going to go. I'm going to call this exercise, I'm going to call this exercise 8_1. And now, since I have this all set, I'm going to go ahead and paste in the code from int_py. So this is pre-existing code. And let's kind of review what this program even does, because we didn't write it or even run through it in class. If I did mention it at all, I probably rolled over it in about 2 seconds and say, here's an example, good luck. But let's take a look at what they're doing here first. So they have a main method defined up here at the top, and that looks like its main thing that it does is it asks the user for a positive integer under 1,000, which it then stores and then passes to a function which does something with it. So, and in the description here it says this program turns an integer into its English name. Oh, isn't that cool? Right? So if I type 1, 2, 3, 4, it's going to print back 1,234, right? That's kind of neat. So that's kind of just a process. If you look at the method that they've created here for int name, it starts by reading the number in, storing it in a variable. It has a name that it's a string that it initializes to empty to start with, and then it's just checking to see how big a number is and how to name it. So if it's saying here if the number is greater than or equal to 100, we're going to append the string 100 to it, right? But it's going to take this other method, which does what is this again? 2 forward slashes. It's a special kind of math. You guys remember what modulus does, right? That's remainder division, where you do your division and it tells you what the remainder is. 2 forward slashes is what we call integer or division, which means it tells us how many times something goes into something without the remainder, right? So not the remainder, but the other part that you get. So what we're doing here is we're first dividing by 100, because the number could be as large as 1,000 or 9,999, right? Or do we just go up to 1,000? Up to 1,000, right? So we see if like the first digit is a hundredths place is basically what we're doing. And then what this does is it extracts that digit, and depending on what that digit is, it returns the word that goes with it. So it's then calling this other method. We also have, that's a digit name. We also have a teen name, so we can do 10, 11, 12, 13, etc. And then we also have one that's for the tens, so 80, 90, 70, 60, 50, 40, 30, 20, right? And it's just converting stuff for us. Right? So now we have to convert this into something that makes sense with a dictionary. And really kind of the goal here is this, that you're going to see that we can do this, first of all, without the same kind of code. We're going to do this with if statements, or excuse me, without if statements, and come up with really kind of a completely different organization. There's going to be some ifs in parts of this, and I just want to just explain the why to that. Here, we are kind of like running these extra statements. So if we get a particular number in a particular position, then we convert it to the name using an if statement. That's kind of weird, right? And it's actually not weird. This is how your brain probably thinks through it. So we have these 3 sets of if statements that does that. So our goal really is to replace all of these. And if you think about what we're doing here, it's this. We are setting up dictionaries that instead of asking if, the number is this, then we'll return that. Well, there's an association that's happening here. So why a dictionary? Well, one's a key and one's a value. So if I have 90 as a key, the value is 90 as a word, right? So why do I have to write an if statement for it? I can instead put that in a dictionary. So that's the goal, is we're going to take these 3 functions and convert them into dictionaries versus functions. All right. So that's where we're actually going to start the program. We're going to put those in as structures right at the top. And not only that, we're going to make them global so the whole program can access them. So where I'm going to put that is right up here. So like right above the main method declaration, I'm going to start to put these in. And what I'm going to do is I'm going to put these in as constants because these are not going to change. So not only are they dictionaries, but they're dictionary constants. Isn't that fascinating? So here's how you're going to do it. So here's the example. And however you lay this out really kind of frankly depends on you. But it's pretty interesting when you start to look at this and start to break it apart. So I want to be really clear as to what's happening too. So I begin by giving it a name. So I'm just choosing one of them first. This is the one that's in my solution file this way, and I think that the way the program is written, I think they do digit, tens, and then teens, but in my solution file it's teens, tens, and then digits. So whatever the approach. Now notice here that I have a dictionary defined in key value pairs. So I go for all the numbers that are in the teens range, so going from the number 10 up to 19, and I take each one of those numbers, list it, place a colon after it, and then give the string value for the numeric key that we provided. The one weird thing that you'll see here is, so notice the backslash at the end of the line. That is a continuation character that you use for these to go from line to line without breaking it. If you're wondering the why, it's there. Yes, it's part of the same structure. And really, technically, that's an escape character, so it doesn't want you to treat it as a separate line of code in Python. because really that should all be on one line. Now this is kind of weird because Python is a language that does not use punctuation to go to the next line. And so really that should all be on one line of text, but that doesn't look good. And you can see that like faint purple line on my screen, or whatever color it is on your monitor. And that's really kind of like the cutoff for a page and screen width. So really, we don't want to go past that point. Yeah, that's why we're doing it. Now, I could also, and just to give you ideas here, right? I could do something like this. I could do teen names, and then give it square brackets, put in a number, and I'm just putting in 13 as an example. And I could have done it like this, right? That would have been a valid way to do it also. Remember how the book did it? With 13 being the key, the number 13 being the key, and 13 is the string being the value. Yeah. I just want to remind you of that. All right, the next one that we have to do are the tens. So we're going to predefine those. So we're going to do 90, 80, 70, 60. And you know what? You're noticing how like the first one, the author put them in order. And the second one he did reverse order. And you know what? He's making a point here. It doesn't matter the order, because that's not how it works. There's nothing to do with the order. I know this is going to take you a moment to type in. I'm going to go ahead and put the third one up here right away too, which of course is for the individual digits. So the single numbers. And you see how those are named. 1, 2, 3, 9. So I'm just going to scroll that up, and hopefully you guys can see that. Everybody can see that okay? I'll take that as a yes. You know, I could be really kind, right, and drop it in the code share for you. But that's way too much like helping you with your homework. That's like basically doing your homework for you. I'm going to pause the video here. You might want to do the same at home. I'm going to make the brave assumption now that you guys are caught up or close to caught up. And remember, you can always go back to the video and check this out. But I think conceptually, at least you guys get this. Now, the next part of this is, I wish in a way that we could eliminate all the if statements, but those basically 3 lines of code that we just threw in are in essence removing all of these. So we can now come in here and blow away these 3 sections below. And so that if you look at a revision of our program, and I'm going to get rid of some of these extraneous comments here, we're now able to almost fit the whole thing onto one screen. And I think that's like really, really cool. Now I am seeing some flags here, so I'm going to have to address those. And I'm hoping they're just indent issues more than anything else. Oh, I know what the problem is. What's the problem? I just deleted the if statements that these are calling, right? So in the past, what was happening is the main processing was happening through these if statements, and it would first check to see if there's hundreds involved, if there's greater than 20 or less than 10 or whatever, and then it would pick the right names by calling the methods. But now we're not using those method calls anymore. So what we're going to use instead is we're going to look at the dictionaries in these circumstances. So all we have to do is put in the correct dictionary syntax to access the dictionary, to pull that stuff onto the screen and make it go. So we're going to do those one at a time here. And once you see how the first one works, the rest of it will be kind of a piece of cake. All right. So first thing is I look at this, right? And we deleted a function called digit name below, but we replaced it with a dictionary called digit names above in all caps. So I'm going to copy this, and I'm actually just going to paste it right into this spot. So I'm using the new name, and because that is a dictionary and we want to address individual components of it, we're going to use square brackets here to do it. So this is going to switch to square brackets. So instead of calling a method with if statements, we're calling a dictionary with key value pairs. Now we're going to do the same thing down below here. None of the rest of the code in the first part of the if is going to change. That's all going to stay the same. Okay. Still dividing by 100 to get the non-remainder part of the answer. And then every time we do that, we also are going to take a separate calculation here to get the remainder, store it in part, and then check it with the next statement. So the next part would be to check to see if it's greater than 20 in the tens position. So in order to do that, we're going to follow basically the same approach. Once again, we are going to replace this name with the one that we have up here. So I'm going to grab tens names. It's kind of hard to say, actually. And put it in this spot. And then once again, we're going to use square brackets around this section. But here's the problem. We are needing to do a little extra math here and in order to get the right value. So what we're going to do is we're going to do our integer division where we divide by 10 and then multiply by 10. And then what that's going to do is it's going to just take the number that's in the 20s or 10s position, so the second digit from the right, compare it against the list based upon whatever the math is. So let's explain what the math does. So if I send in 80 and it divides by 10, what's the result? 8, right? Why do I multiply by 10 again? So that it compares to the list, because the list has 90, 80, etc. Now, I could argue that I wouldn't have to do that math there if they just had the single numbers in there. You could do that. You could totally do that. But I'm just doing it mathematically. And the reason why I do the integer division first is to get rid of whatever's in the ones position. So I divide by 10 and then I multiply it back. See what's going on? But the first division will just give me the 8, not the 0. And then in the next step, I'm doing the mod again to get the remainder, because the remainder gets passed on to the next equation to see if it falls in the greater than 10 range or the teens range. Once again, on that one, we're going to replace the name with the dictionary name. So we're going to throw in teen names. And once again, switch to square brackets. And in this case, we're already down to the point where we know that we're in the 10 range. We don't really need to do any math to figure it out. We're just looking to match it with one of the numbers in the teen thing. So we're going to come back with 2 digits. We know it's going to start with 1. It's going to be between 10 and 19. It has to be, because everything else that was 20 or greater was already filtered out in the previous step. See the logic there? And then finally, we will set part equal to 0. That's only if this part hits, mind you. And why would you set that to 0? Well, think about it like this. If I send in a number between 10 and 19, I'm in essence figuring out the last 2 digits, right? The tens and the single digit. If it catches in the previous scenario where it's 20 or greater, I've only figured out that it's 20 or greater. I haven't figured out what the single digit is. So if this part doesn't hit, if it's not a teens, then it will come to this part with that remainder from here, which will be a single digit. And then we just look that name up in the digit names dictionary here. And I think that's really a very, very clever way to get this to happen. So think of all the code that we just replaced with these simple dictionaries. Now, whether it works or not, that's a separate story. I don't have any flags or highlights or anything, so I think my code's all good. I'm going to do a Control-S and save it. And then just to kind of refresh, what it's going to do is it is going to prompt me for a number. And that is the entirety of the code on the screen. That's all the code you need. Everything is there. It's going to prompt me for an integer under 1,000. I'm going to type it in, and then it's going to give me back the verbal name of that number. So let's go ahead and run this. All right, so enter a positive integer. Let's do, I did 953. I'm pressing enter. And it looks like it's doing the right thing. And what you should do, I might even suggest you put a program like this into a loop, honestly. Let's put something in there with some teens or 20s. How about run it again. So it seems to work. Everything I threw at it worked perfectly. Pretty simple. And I'll tell you what I like about working with dictionaries is this is kind of how your brain works. In a way, I think that your brain is kind of organized this way where you're associating, what you're thinking of as a number with a particular word. All right, so that's exercise 8.1. All right, that completes the first one. Let's move now to the second exercise. So I'm going to pull the book back up on the screen here and then figure out I am now going to do 8.2. All right, so this one says write a program that counts how often each word occurs in a text file. All right, that sounds, I guess, kind of simple and kind of complicated both at the same time. Believe it or not, the code is not that bad. So we will have to obviously find a text file to use. And, we could always copy the ones that we were using last week. Where we had like some song lyrics or whatever that we were using. Or if you have some other text file that you have access to, that's fine. Let's go over to Spider and create a new program. And let's do a save as right away. And we're going to call this exercise 8.2. And just to review those instructions, write a program that counts how often each word occurs in a text file. Now we're not being told to do this, but I'm going to tell you what, my first thought is I got to deal with the text file again. So we're trying to keep those skills alive. And so what we're going to say here is I could either just automatically read one in. Yeah, you could do that. I would be fine with that. But I think it's more elegant to actually have the user declare the name of the file. We're assuming that it's in the same folder, although you could put in a whole path if you wanted to. But I'm going to prompt the user and ask them for the file. So I'm going to do this. I'm going to start here. So this is the first thing we're going to do. We're going to read the file name from the user and open the file. I plan to use one of the files I created last week. So it's going to input it. It's going to open it. And then what does little r do at the end of the open command? Reads it. Right. We don't need to change the file, right? It doesn't say write changes to it. We're just going to read it in and count the words and how many times they occur. All right? Hey, you know what? Since we're counting, we probably want a variable that's going to store our count. The question is it really a regular variable? But actually, what I'm going to do is I'm going to create a dictionary. I'm going to show you my thinking here. I'm going to call it something that looks like it's a counter variable, but it's actually building the dictionary as we go. and we're going to store it all in there. And remember, if you want to declare an empty dictionary, just use empty curly brackets. All right. Next step is going to be to actually start counting the stuff in the file. So you think about this, we're going to have to read through the file line by line, and then split it all apart. Because you remember that? You run the split command, so every time it finds a space, it assumes it's a new word. And then for each word, we're going to go through and look if we already have it. And then if we have it, we're going to throw it, or if it's new, we're going to throw it into the dictionary. And if we haven't encountered it, or if we haven't encountered it yet, it goes in the dictionary. If we have it, it doesn't, right? And then we do a little math. I mean, it's kind of the thing. And then we're going to do an output at the end that's going to show everything in the dictionary. That's actually really easy to do. So what sounds like it's really complicated is actually not that bad in this language. One of the things I'm really kind of starting to like about it quite a bit, frankly. So let's start by getting the beginning of our loop going here. So the first part of the loop, we're going to set up the loop, and we're going to say for each line in the in file, that's the INF, right? We're going to take and store into words the line that we're splitting apart. So let me ask you right off the bat, what is words? It's a list. So words is actually going to become a list, because if you take a line of text, it's got a bunch of words on it, and we're splitting it into a list. We're splitting it into a list of words. So now that we have the first line of text read in and split apart into a list, now we're going to take the list and read through the list. Get the logic? Right, so now we're going to set up another for loop here. So the for loop's going to go like this. For word in words. Now, the list is called words. And we're now declaring another variable that's going to hold each individual word from that list of words. And for each one of those, if the word is in our dictionary, so it looks for it in counts. If word in counts, we're going to say that word we're going to do exactly this. We're going to place it in here and then keep a count of that word. So I want you to think about what's happening here. The word that we read in that's unique is becoming the key. The number that we're adding is becoming the count. So the key is the word and the number is the value. So then we're going to output each word and how many times has it occurred. And every time we find the same word, it just adds one to the total. So it changes the value like this. It seems kind of complicated, but it's actually kind of powerfully simple. And then we're going to do an else here. And in the else, if it doesn't find the word, then, in other words, if the word's not pre-existing, then it just sets it to 1 to start with. Believe it or not, that's all the processing you need to make it happen. I want to get back to the margin here, and it's not letting me. There we go. All right. Finally, don't forget, close your file. In fact, close your file so it can be released for further processing. I don't like the way it auto indents here. I feel like I have to get the mouse on the screen. That's kind of troublesome. All right. And so we're going to do a close command. So we're going to close the in file. And then we're just going to do output, folks. Now, because we have a structure here that we're going to output, we're going to iterate through it. So we're going to use a loop. There's no reason to do it manually. Because, frankly, who knows what file you're reading in and what words are in it? You don't know to tell it, so you want it to happen automatically. So I'm going to say for word in, And watch this, I'm going to sort it too. Sorted count. So not only that, they're going to be alphabetical on top of it all. You know, frankly, you could leave the sorted thing out, and I would be fine with it. That's not. It didn't ask us. It didn't ask us to sort it, right? No, not at all. So that's not a requirement. It's just something I'm kind of opting to do. So for that, we are going to. I'm just curious as to why it's not indenting automatically for me here. All right. We are going to output, we're going to print to the screen. We are going to do a little bit of formatting. So I'm going to do a %S, and I don't know if you guys remember what these even mean anymore, but I'll tell you what, you might want to review them before the final or bookmark that page because I might ask a question or two about it. And then we're going to feed into it in a list the word and then how many times that word is appearing. And I hope this is kind of making sense to you. When you see the output, I think it makes more sense, frankly. So I think that's pretty cut and dry here. I think I have all the stuff in here that I need. Just double checking my source file and my output. I'm going to go ahead and do a Control S. I'm going to get Brave and run it. However, hey, wait, we need a text file, don't we? All right, let me do a little file management here. So I'm going to pull my file folder back over. And I think last week I had a couple, and you know, I don't even remember what's in them. I think this is probably the most notable one. Let's see what it opens up as. Yeah, this is what it opens up as. You know, I could probably do better than this. I should probably go out and get the real words, right? All right, let's do that. Let's have a little fun with it. I'll go out. I'm going to pause the video for a second while you guys copy code, and I'll grab the actual lyrics and add them to my file. All right, so here I am editing my She Loves You lyrics. So I went out online and just Googled them, and here's all the lines in here, right? And there's a lot of yeahs in here. So we're going to read this file in so you can see we have quite a number of lines here. So it's 41 lines in the song. I'm going to make sure I save that, and then I'm going to make sure I move this file over to the right folder. So now I got to find my file folder, and let's do a refresh here, make sure that file grew a little bit. And we're going to copy it over into my Chapter 8 folder. I'm doing that on the other screen, by the way. And my file name is, just so you can see it, shelovesyou.txt, all lowercase, no spaces or anything weird like that. All right, so when I run the program, that's what I'm going to type in. So enter the name of a file, shelovesyou.txt. Now, if I was smart, okay, and I realize we've already learned this concept, I could set up an exception handler or an if statement just in case it didn't find the file, right? You know, remember all that stuff? And if you're a really good programmer, you would totally do that every time. I'm just cutting to the quick and just getting it to happen. It didn't tell me to put that stuff in, so I'm not putting it in. But if I was really writing a program, I would absolutely put that stuff in. You guys understand me? Right? I'm not skipping over that because it's not important. It actually is important. You never want to set up your program so that it fails. I'm just assuming that it will be okay. So I'm expecting some verbose output here. So you can see how I'm like already rearranging my screen to allow for it. I think that's about as much as I can get out of it. So I'm going to hit enter and see what happens. Well, that was interesting. And apologize because, but, I, it's, pride, she, well, yeah, yes, you, you're, a, almost. And I think it's kind of interesting. It did alphabetize it, but you notice the capitalized words went first? It's kind of interesting. Where's the word yeah? Well, capital yeah is twice. Looks like lowercase, only 18, so only 20 times? She loves you, yeah. You know, I'm just trying to think of that. Doesn't seem like nearly enough. I guess if you multiply it by all the Beatles and how many of them are singing it, you really have more. But I think it's fascinating. It seemed to work just fine. Isn't that cool? But notice that they also have a distinction here between yeah and yeah, comma. Because now I'm noticing yeah. Wait, all right. There's 9 more without a comma, so that's what 27, 29. So I'm counting 29 of them total. Do you guys remember that there was also special code that allow you to remove commas, question marks, and periods? You could write that code in there too if you want. Or whatever, however you want to do it, you could totally do that. You could even get sophisticated and you could write a separate program that would strip all that stuff out and save it back to the file and then run it through this program to do the word count. But I think this is like really, really cool. You can take any text file and feed it in here and do the same thing to it. And the amount of code that it takes is minimal. And I think that, frankly, folks, that's probably the most impressive part about it. All right. We are actually 5 minutes past class end. I have an important meeting I have to attend in about 5 minutes. So we are going to cap it here. What I would encourage you guys to do is this, though. I want you, you're not, and I know the people here in the classroom are always in the habit of leaning on me to help them do their homework, and I really kind of don't mind. But there's 8.4, 8.10, and 8.17. All of them have examples in the book, but I think that the next problem, 8.4, is a really interesting one because it talks about how people figured out all the prime numbers that there are, and it gives an example. So you guys know what a prime number is? It's a number that can only be divided by 1 in itself, right? And they actually have computers out there that run more complicated versions of this program that are continuously crunching to find the next prime number. So like once you get past all the lower level ones, you get to ones that are astronomically huge that are still prime numbers, and those are considered almost like magic numbers in ways. Right, and it might even take like a year for a computer to run to find the next one. It's like that kind of complicated math. But they show you the formula here, or the technique for doing it. And then once you see the technique, obviously there's probably be some sort of a loop here. Yeah, this is a really interesting problem, but I really suggest try to solve this one. See if you can solve it next time when we come back. We'll see what you guys came up with. It'd be kind of interesting. And of course, you can have whatever it outputs or stores or whatever, you guys can put it up on screen, store it in a text file if you want, right? You take a text file, and then go online and look at lists of prime numbers and see if your program worked. Kind of interesting. All right, see y'all next time. This is the end of exercises part 1 for chapter 8.